Basically, when you go up to a condensing unit outside, checking your superheat and your subcool, you're checking your high side and your low side. And basically all you do is you check it, put your gauges on, high side, low side, get your pressures, and then you'll need a pressure temperature chart because all pressures are going to equal temperature. So whatever they are, I mean, I put 100 and 300. A lot of times it's a lot higher than that if it's hot. So you got to get that. It correlates to a temperature. So you get those temperatures, and then you get the actual temperature off of it with taping a probe to it, or like putting a clamp and getting the actual temperature of your suction in your high side. And that just tells you, with those two numbers, once your PT chart, you subtract them, and then you can, on your high side, you'll get your subcooling. On your low side, you're gonna get your superheat. And that's just how much heat is actually gonna
subtract them again. You just take the two and subtract them from each other?
Exactly, yeah. So once you get your pressures like 100, what that correlates to the PT chart for 410A, usually, now it's 454B, whatever that would transfer over to on a pressure temperature chart, you get that number, and then you get your actual temperature right at the inlet outlet of the condensing unit area. And we're checking right next to where the condensing unit is, so those temperatures are going to change from one side to the other, but it just tells you how efficient your condensing unit is. Your condensing unit, as you know, it condenses from vapor down to a liquid, so it's sucking back in vapor and pushing out, condensing it down and pushing out liquid. How much liquid is in there? If you've got a crazy amount, well, it might be a cooler day. If you don't have very much, I mean, if you have very, very low or no superheat, there's a problem, That means this whole thing is pretty much just turning back into a liquid. If you got really high subcooling, that could mean some problems, either low charge or and then one of the reasons that we are checking this is just to kind of know what's going on, the efficiencies, the levels. That's how we tell a lot of times. With a TXV, if you're running a TXV instead of a fixed orifice, you're going to be running probably closer. We're shooting right around for your, let's see, I think for the super or subcooling is, I wrote my notes down here. With a TXV system on a superheat, checking your low side, right around that 8 to 12. If it's a fixed orifice, you're gonna have a little bit higher superheat coming back because they're less efficient basically. So you're picking up more. It says from the factory, give or take, between 10 and 20. 20 would be a little high. Probably right around that 15 mark is where you're going to want to be, even a little lower. 12, 13 would be pretty solid for your superheats. On your subcooling, it's going to be a little different. With a TXV, I'm sorry, that was on the superheat. So that I was talking about. That's all that superheat is. It's just how much extra heat the evaporator is picking up. The reason you want superheat coming back to your condensing unit is basically an insurance. Does that make sense? It's the extra heat it picks up after it changes from a liquid to a gas. So it's going to change from a liquid to a gas at a certain pressure, a certain temperature, because it's picking that heat up from inside the house, from your A-frame or A-coil or whatever's in there. They're changing every other day. It's like, but we'll just call it an A-coil. Your evaporator coil is picking up the heat and pulling that heat out of the house, taking it outside, you're expelling it. That coming back to your condensing unit, it picks up that extra temperature. That extra temperature tells us that what's coming back to this condensing unit is definitely a vapor. The condensing unit, what the compressor deals with, only vapor. What comes into it, vapor. What comes out of it, vapor. It takes that low pressure vapor, compresses it, and I'm saying this for you, Matt, it compresses that down and turns it into a high pressure vapor that flows through the condensing unit, expels the heat, condenses it back down into a liquid. And you only want a certain amount in the condensing unit and the evaporator coil on both sides. That way, they're working efficiently. You know, if all your, let's say it's a cold day outside, one of the reasons it's hard to do these checks if it's cooler out, is because of this test. It's turning that vapor into a liquid way too soon. So it's all your liquid refrigerants outside, and it causes problems because it's starving the inside evaporator coil. A little bit advanced for, you know, your first day, but if you understand this, it will definitely help. Basically, in a nutshell, and I'll just kind of read it from my notes here, your suction pressure tells us what's going on in the evaporator coil. It's just our temperatures. Your high side pressure, your superheat, tells us what's going on in the condensing unit. And then your subcooling means the more liquid is in the condensing unit. That's when, you know, a cooler day outside, or I don't know, you spray water onto the condensing unit after you get done cleaning. It's gonna be more efficient. It's evaporating off, and you're gonna condense that vapor into a liquid much sooner. You're gonna have way more liquid over here if you're on a cooler day. You know, it's all liquid up here, just a little bit of gas going to it. And then you're starving the evaporator coil. So you'll get this weird thing, especially on a fixed orifice. It could start to freeze up right in the very beginning. If you're a low charge, again, you might not have as much liquid out here. You know, your pressures are gonna be lower. Your subcooling is gonna be off. Your superheat's gonna be way high. You're gonna be picking up too much heat because the heat that it's pulling across, there's not enough gas inside of that. Does that make sense? So,
It reminds me of a still.
you know what? It's actually kind of the same principle. The stuff going through is condensing. You're using it as a condenser. You're boiling it off.
Yeah.
It's turning into, you're getting the alcohol and leaving the water at the bottom. It's a little different, but same kind of a principle. You're boiling that off and you're condensing it back down into a liquid where it dribbles out the end. And at different temperatures, you know, that's why they like some of those ones, they turn up and down the temperature to get the right stuff coming out. You don't want to boil it so that you're getting all the vapor and the moisture off, but you don't want not enough heat where it won't do anything. So if we know what's going on here, this can tell us a lot just by hooking up your gauges and getting your temperatures.
And you don't have to search and find blood filters and coils.
Well, yeah, and there you go. That can tell you a lot too. I mean, it won't tell you everything, but you'll see something off. Basically, like your subcooling
across that coil at all.
Yeah. If you're not getting enough airflow, it's going to affect your subcooling. You know, it's going to throw it off a little bit. You might not have as much because it's not picking that heat up.
I feel like that's part of what we were dealing with the cigar shop before we added the extra return in there.
Oh yeah, if you don't have enough return air, you're choking that airflow down. Airflow is a huge deal. We're gonna get into the airflow more later, but absolutely, yeah, airflow can affect what's going on in our superheat and subcool. In fact, you can throw your gauges on before you even walk into the house, and you'd be like, oh, well, I better be checking airflows, you know, filters, fans running up to speed, ductwork, correct size.
Might be frozen.
Could be yeah, if it's froze up.
You see really weird pressures.
Well, I mean, if it's froze up, the inside unit, you're not picking heat up. So what do you think that's gonna do to your superheat coming outside?
It's just gonna drop it down.
Yeah, absolutely. You're not gonna have very much because it's not picking up the heat that it would if the coil was clear and the air was able to flow across it to pick up the heat. And then flowing outside, you're checking, and oh my goodness, I've only got 2 degrees superheat. It's like 2 degrees is better than nothing. If you don't have superheat, what does that tell you? If there's no superheat coming back from the evaporator coil to the condensing unit.
Bad piston. Piston's plugged up.
No, not usually. If your piston's plugged up, you're going to not be sending enough refrigerant through the system. Then if your piston is plugged up, what would that do to your superheat?
Make it really high.
So you see,
So the opposite effect.
exactly, the plugged
It's
system.
just plug in it.
Yeah, because you're not sending enough refrigerant back because there's a restriction in the line. So yeah, you're gonna have super high superheat, and so you're gonna be checking like, oh, well, I'm only like my pressures are all off. You know, I mean, on a partial plugged system, you will have a higher head pressure and a lower suction side. Now, if it's a complete restriction, you'll get some weird stuff. Like the pressures will come all the way up and then go back to zero.
I've seen that.
We've seen it on refrigeration systems. It happens all the time, especially those little 134A systems with the cap tubes plug up, and then or even a completely plugged up dryer filter. Plug dryer filters, it's a restriction in the line.
Same kind of thing.
Same exact thing. I mean, basically what you're doing is you're just flooding the system. It's picking up a ton of superheat, and it's just not letting the refrigerant flow through fast enough. So your superheat will be way high. If you're seeing way high superheats and you know your charge is good, then you're looking at plugs in the systems, dryer filters, TXVs. You know, if we're welding without nitrogen, well, that stuff flakes off. You've seen it on the outside. It flakes off. You can get in the inside. You can plug up stuff. I've seen it happen.
Yeah.
And this test can check it. You're like, oh crap! Now I gotta pull all the refrigerant out, figure out where this plug is. Probably in your dryer filter. Actually, it'll probably be in your fixed orifice, and it's plugging everything up. So with those tests, if you can check those tests, hook up your gauges, get the actual temperatures, run that superheat subcool, write it all down. If you call me and I'm looking at that and I'm like, oh, your superheat's at like, you got 25 degrees superheat. We got an issue, like a serious issue going on. Now, granted, I'm just throwing numbers out. If you see that number over 15, even on a fixed orifice, like, probably want to start looking. If it's a super long run, it could be that high. I mean, if the insulation's all damaged and it's just sitting out in the sun, it can throw it off.
I was gonna say with the Fujitsus, they were telling us with the really long runs that we were gonna have a higher superheat.
Exactly. I mean, it just is what it is. The longer the run, no matter how well the insulation, there's still going to be some infiltration there. You're still going to pick up heat. When it's running, your suction line's running back to the thing. That's why we insulate it, is to keep that down. We want some superheat, but we don't want an excessive amount, because then this thing, your condensing unit's working harder. It's picking up more heat. It's possibly going to damage your compressor. Not getting enough superheat, why would that be a problem? I'm talking superheat on the low side. So your suction line coming back to you. Matt, not getting enough superheat coming back to your condensing unit. Why would that be a problem? Actually, it might be overcharged.
Really?
Yep.
Too
If
much
you're
refrigerant.
too much refrigerant, not picking enough heat up, something is happening. But what could be the problem?
Plugged coil?
Yeah, absolutely. Plugged coil would definitely cause not enough superheat because it's blocking that airflow. It's not able to pick up that heat. And what is the evaporator coil doing?
It's
Think of
taking
it.
the oil and bringing it back, flowing through. It's taking the superheat across the coil.
Well, you're picking up the heat across that coil. You're transferring that heat. If that's plugged, you're not picking that heat up. The air's moving too slow. So your coil's gonna freeze up. Your superheat's gonna drop. It's not going to turn back into a gas. So you have liquid,
Going straight to your compressor.
which,
Chilling.
yeah, you're slugging your compressor. That's what liquid refrigerant coming back to your compressor slugs that compressor. Compressors do not deal with liquid. They only deal with gas. That's why we're checking that.
That's why compressors get killed so often when it freezes up.
Yeah, absolutely. Yeah, because if you get liquid refrigerant going back to that, let's say it's in the refrigeration side, you got the pistons. They can't compress. It just snaps, breaks those little piston arms, and it just destroys them. The little rings, whatever it does, they're done. Scroll ones, they can handle a little bit better, but they make a crazy noise, and then they're usually going to be done too. So no compressor really handles liquid. It's not supposed to. They're not designed to do that. Now scrolls are a little bit more forgiving, but even they will break, and it'll bust the little things inside of them and then they're toast.
Makes sense.
And then you got a whole other mess of issues with junk going through the system. So anyway, that is part of what the test that we should be checking pretty much when you first walk up to any kind of condensing unit. You knock on the door like, hey, let's go check the thermostat, make sure it's on, go outside, put your gauges, do this check. When it comes to preventative maintenance on an outdoor condensing unit, superheat, subcool, this is what you're looking for. And now, sometimes if you're in the morning, they're gonna change a little bit. So you'll have to understand, you're gonna see some, but you want a range.
That's where you go off the PT chart.
Yeah. And you want that range of superheat and subcool. Let me give you just the rule of thumb, and these are just rule of thumb, so take it with a grain of salt. So your fixed orifice on your superheat, coming back, your fixed orifice 10 to 20 it says, but stick around that 15 mark. TXV systems, see a bulb going over there? The TXV, and I know I'm throwing a lot at you. If you think of a TXV as a constant superheat tool, it's trying to maintain at a certain level.
Regulator.
So it modulates up and down off of what it senses, the little bulb coming over to the
It
suction
always
side.
reminded me of a modulating gas off.
Yeah, it has a little needle
Where
inside
it
of them, and
senses the
again,
heat
we'll
and
go
opens
over
and
that.
closes.
We'll have a whole thing just on TXVs.
We should, just because they're kind of a pain sometimes.
They can be tricky. They can hunt around. They can do some weird things. Sometimes they can slam shut. Sometimes they can back all the way up. The little bulb or the little head can go. Anyway, it doesn't matter. The reason that you have a TXV here, you have to have a certain amount of pressure to make them work. So if they're really low charged, they'll do some weird stuff. They'll shut themselves all the way down, or actually if they're low, they'll probably seat themselves all the way back. And it's not good for them to go all the way back up and stuff. They kind of want to modulate there.
I get why people like them, but I don't.
Make the system more efficient. They maintain a better, more constant superheat because it has that bulb sensing the superheat coming right out of the evaporator coil.
Maybe it's getting a little harder here, but just the efficiency, I don't know.
Well,
I've never really noticed the huge difference inside, how quick it pulls down, or
not
any
usually.
of that.
It's just the efficiency. If they're trying to hit
Just
those
the unit,
ratings,
that's it.
you can't put in a fixed orifice and hit a rating that they could get something back. And they do it in refrigeration systems because they want right at about 8 degrees superheat on some of those things.
Refrigeration.
Because you want that system to be really cold.
I'm just against them.
Well, get used to it because they ain't going away.
Because
so.
they plug so much, and we always end up running into issues with TXVs.
So basically, if your superheat's too low, you have too much refrigerant, it can come back and slug your stuff. If it's too high, it's underfeeding. We have either restriction in the airflow or poor cooling, like you said, a dirty coil or a plugged filter or the fan, the capacitor on the fan is getting weak and it's not spinning that fan up to speed. This test.
If the condenser's plugged, won't it just be sending basically gas back because it won't be able to condense it down?
Correct. Yeah, you're not going to have let's say the fan is the capacitor on the fan out here isn't running and you're not expelling that heat. It's not pulling that heat out of there.
Weak.
Yeah, your pressures are first of all going to be through the roof. But even if they're not and it's running slow and it's able to kind of keep up a little bit, your subcooling is going to be like nothing. You're not going to have any subcooling. And it's just going to be just crazy hot. First of all, that'll be a clear indicator like, oh, everything is just blazing hot. Either the coil's filthy dirty or the fan's not running up to speed. And I've seen this where the homeowner's like, I don't like the way this looks. And they build this crazy doghouse thing around it and then they can't breathe. So, there's all kinds of stuff. You got to go take a look at it. I mean, the obvious things you're going to catch. What's that?
They built a patio over one side.
I mean, yeah, they squish that thing
It was
down
enough, I think, but
you get that flowing back around and into it. So it can cause problems.
Yeah.
It might still work. But like I said, your subcooling It's not able to cool that refrigerant down well enough. So absolutely, yeah, this would be a test. Be like, oh, you know, it's working, but your compressor is getting real hot because it's not able to pull that out of there and expel that heat like it should.
We're gonna have to put a grate in your deck. This is to work.
You know, and like I said, you're gonna run into issues. You're gonna see stuff. People and systems are put into situations in different applications in different areas. We work with what we're given, and we do the best that we can. In an optimal world, it would be a flat surface on every single thing in a house with a great area to put it, with all the room in the world for it to breathe.
Nice dirt to level it out with.
Gotta have everything.
Yeah.
But like I said, we do the best with what we're given. I mean, yeah, we want to keep that level, you know, bust the shovel out, get that level. It being tipped is not going to really affect the refrigerant. It's all about the oil in the compressor for another time. So as long as you guys kind of understand superheat, subcooling, you know, your subcooling is getting rid of the heat and your superheat's picking up heat. You want a little bit because you want to make sure that's a gas coming back here. You want a little bit going back because that way we know that we've dropped it down. We dropped it down below where it condenses, so we know that's a liquid. We don't want gas going back to the TXV. It can't meter gas. It meters liquid. So everything that the TXV deals with is all liquid. So I mean, if you drew a line this direction, it's you want, well, I guess it would actually be more this direction. You want all gas coming back and all liquid from the condensing unit going to it. Any questions?
Where do you find the chart?
Oh.
I heard you say something about PT chart.
Yeah, PT chart.
It's on the unit.
A lot of times I'll give you one, but they have apps. I use one on one of my phones where it's just a PT chart, and I'll show you. And you go scroll over to whatever the refrigerant is, 454B or 410A, R22. I mean, in air conditioning, these are usually what you're going to be dealing with. Not so much the R22, it's kind of going by the wayside. There's still some systems out there that still use it, and people are adamant about hanging on to these antique systems that are terrible. But you know, whatever, it is what it is. And
To be fair on that one, R22 seems to run fantastic.
it was a great refrigerant. It just, with EPA laws, things have changed.
So much.
And now, due to cost, that's what they're doing. They jack the cost up to get rid of it. And
The R22 is pretty expensive.
oh yeah, it's expensive. And then
1,500.
in refrigeration, we're dealing with gobs of different 404A, you name it. 134A. I mean, and 134A is in cars. We don't really deal with automotive, but it's in vehicles. Same kind of thing. You just correlate with what is in the system, and you do the exact same test. Doesn't matter what kind of refrigerant it is. Doesn't matter if it's on a walk-in freezer, a massive system at Costco, or a itty-bitty little system that keeps a couple of pops cold. You can run this test. I mean, sometimes they don't give you taps, but if you can do this test.
You know, you could sort of check. No, not really.
No, absolutely. In fact, there has
Check
been a
the stuff.
situation. No, not really, but you can check your temperatures, and there are ways of knowing what's going on in the system just off of your temperatures, where you just take the actual temperature. You know it's running 134A. It's going to be an approximation. Do you really know everything? No, but it'll get you close.
I'd like to go over that next time, maybe.
What's that? Just how to check it with just temperatures?
just a simple check. Just
Absolutely.
because it'd be nice on small systems that don't have taps. You don't want to put taps on them because then they leak.
Or yeah, you know, it takes 8 ounces of refrigerant, and your gauge is going to rob 4.
Yeah.
You know, so yeah, absolutely.
It'd make it kinda
There
nice.
there are smaller little things that you can tap into the system and use where they don't fill the whole line up. You know, I've seen Phil Peace makes like a little thing.
yeah, the little baby electrical ones. Those
Yeah,
are
and they
cool,
just tell you what the pressures are. Those are kind of nice, so you don't rob too much.
Then if you have to fill it, you can.
Then you drag out, put your 14-foot long hose on, and fill that system up.
It'd be cool if you could put your gauges on the back of that after you put it on, so you didn't have to take it off. When, you know, like just put it onto the meter. You could still see it on your phone or something. That'd be pretty neat.
I've
But-
seen people use like a little T.
Yeah.
for those.
That makes
Oh yeah,
sense.
and then they just plug back into it and add charge. Yeah, that's actually a really good idea. I never even thought of that, but yeah, that's a great idea. For the small systems, that would be fantastic. Just put a little Schrader valve in the T and put a cap on it, and when you're ready, hook up. You don't even have to hook gauges up then. You can just do a hose right directly from your tank over and just kind of
Yeah.
fill it to the pressures you need. So yeah, if you know what's going on with your temperatures, correlated using a PT chart, which I'll show you where to get, you can know a lot of what's going on in the system. It can tell you, oh, my airflow is, something's messed up, so it's something to go look for. Coil dirty, fan not running up to speed, you know what to look for. So there you go.